I welcome to our session. So now we go to see type 5. Type 5 is nothing but R of x. So that is a combination of exponential term with some other function. So that function we call as g of x. That g of x may be either algebraic or trigonometric. That is either x power m or sin ax or cos ax. So procedure to find the particular integral. So particular integral is equal to 1 divided by f of d into r of x. So that is r of x is nothing but e power x gx. So you bring this the product of algebraic term is there, means bring this exponential term in front, replace d in terms of d plus a. That the a is nothing but coefficient of exponential x in exponential term. Then suppose if it is g of x is algebraic term, we are trigonometric term. After that we will use the previous terms. So this process is called exponential shifting. So now 1 divided by f of d plus a g of x can be evaluated using the method in the type 2, 3, 4, depends upon the type of the function. Next, type 6, r of x is equal to x power m sin ax or x power m cos ax. So procedure to find the particular integral. So e power iax is equal to cos ax plus I sin ax. So real part of e power iax is cos ax, imaginary part of e power iax is sin x. So hereafter in this method, so if it is cos ax is given, means instead of cos ax we can replace so real part of e power iax. Suppose if it is sin ax is there, instead of sin ax we can replace imaginary part of e power ax. Here e power iax is there, I is missed, e power iax. So particular integral is equal to 1 by f of d into r of x. So x power m into sin ax. So imaginary part of e power iax. So bring this imaginary part in front. So now after that we have to solve by, this is of the form type 5. So therefore solve by the procedure solve by type 5. So e power mx cos x means so real part of e power ax. So again this is also in the form of type 5. We can proceed is type 5. So problem number 1, solve d square minus 2d plus 2 into y is equal to e power x into x square plus 5 plus e power minus 2x. So this is a given equation. So the given differential equation we need to find the complementary function. So for complementary function we can replace r of x is 0. So replace d in terms of m. So therefore since it is a quadratic equation, solve this, we will get roots are 1 plus or minus I. Therefore this is a complex roots, alpha is equal to 1 and beta is equal to 1. So replace alpha and beta equal to 1, we will get complementary function is equal to a power x into a cos x plus b sin x. Now to find the particular integral, so 1 by f of d into r of x, split into three terms. So that is particular integral 1, particular integral 2 and particular integral 3. First we go to find the particular integral 1 by f of d into x e power x into x square. Since this is a type number 5, so product of exponential term with algebraic term. So bring this exponential in front. At the time we can replace d in terms of d plus a. Here a is nothing but 1. Therefore d, wherever d is there, we can replace d plus 1. So simplify this. After the simplification you will get this. So then we can use the type number 3, e power x into 1 divided by d square plus 1 into x the square. So therefore 1 plus d square, bring this numerator, we can get 1 plus d square the whole inverse. So by using the binomial theorem we can expand it, we'll get this. Now multiply the x square. So up to maximum second derivative only is non-zero, third derivative onwards it is 0. Therefore we can neglect the higher derivatives. Therefore up to second derivative only here we have. Therefore 1 into x square is x square, d square of x square. So therefore d square of x square, d of x square is 2x, d square of x square is 2. So d cube d power 4, higher term tends to 0. Therefore simplify this, e power x square minus 2. So now to find the second particular integral. So 1 by f of d into 5. So e power 0 x. So replace d in terms of 0. So we will get, so 5 by 2 into e power 0 x. E power 0 x is 1. The 5 by 2. So now to find the And third, particular integral. So particular integral is equal to 1 by d square plus minus 2d plus 2 into e power minus 2x. So therefore, wherever now we have to use the type number 2. Wherever d is there, we can replace in terms of a. A is nothing but minus 2. Replace it and simplify that one. We will get particular integral is equal to e power minus 2x divided by 10. So therefore, now we can substitute complementary function particular integral 1, particular integral 2, and particular integral 3. So we will get a solution. Next example number 2. So solve d power 4 minus 1 into y is equal to d power x cos x. So the given equation is d power 4 minus 1 into y is equal to d power x cos x. So since it is a product of exponential and trigonometric term, therefore this comes under type number 6. So now we need to find the complementary function. So solve d square minus 1 into y equal to 0, replace r of x is 0. Therefore, since the auxiliary equation replace d in terms of m, therefore m power 4 minus 1 equal to 0. Therefore m square plus 1 m square minus 1. Therefore we can write like this. Therefore m is equal to plus or minus 1 and plus or minus I. For the first two roots plus or minus 1, the roots are real and unequal. But in the second root is a imaginary root. First root is a real root. Second root is the imaginary root. Therefore the first two roots are real and different. And the other two roots are complex roots. Alpha is equal to 0 and beta is equal to 1. Therefore, this is a complementary function for the first two roots e power minus x plus e power bx. The remaining the second root here alpha is equal to 0 and beta is equal to 1. Therefore, we replaced it. We will get c cos x plus d sin x. Now, to find the particular integral, so replace your r of x and f of d. So bring this since it is a product of exponential term. So we need to bring it in front. So e power x into 1 divided by, at the time we can replace d in terms of d plus a. Here a is nothing but coefficient of x in the exponential term. The coefficient of x in the exponential term is 1. Therefore a is equal to 1. Therefore replace d in terms of d plus a is d plus 1. So then we have to expand d plus 1 the whole power 4 like this. We'll get simplify plus 1 and minus 1 get cancelled. So now we have to use in the terms of trigonometry, that is cos x. Here d power 4 we can split in terms of d square into d square. D cube we can split into d into d square. So since it is a trigonometric function, we can use type 3. So type 3 is nothing but d in terms of d square in terms of minus a square. Here minus a is 1. Therefore minus 1 square is minus 1. Therefore replace it. Simplify that one, we will get this. So therefore, which is the particular integral? Therefore, general solution is complementary function plus particular integral. Replace the complementary function and particular integral, we will get a solution. So next problem number 3. So d square y by dx square plus 2 into dy by dx plus y is equal to e power minus x divided by x square. So therefore, this is a given problem. Therefore, complementary function, replace d in terms of m. So we have to solve this. We'll get m is equal to minus 1 and plus minus 1 are the roots. Roots are real and equal. So therefore, replace it. We will get a complementary function. Now we have to find the particular integral. So particular integral is equal to 1 by f of d into e power minus x divided by x square. Therefore, we can bring here we can bring this exponential in front. At that time we can replace d in terms of d minus 1. So plus 1 and minus 1 get cancelled. We will get this. So 1 by d square. So 1 by d means you can differentiating once. D square means we can differentiating twice. Similarly, integration is the reverse process of differentiation. Therefore, 1 by d means you go to integrating once. 1 by d square means you go to integrating twice. So therefore, e power minus x into 1 by d square into x power minus 2. Bring this x square in the numerator. We will get x power minus 2. Therefore, we can integrating once. We will get this. Next, we go to integrating second time. We will get this, which is the particular integral. So therefore, the general solution is y is equal to complementary function plus particular integral, which is this. So the next problem, d square minus 2d into y is equal to x p e power x cos x. So this is the given equation is this. So therefore, to find the complementary function, solve the replace d in terms of m. Solve this, we will get m roots are 0 and 2. So therefore, roots are real and different. Since it is therefore this is the complementary function. So particular integral we need to find this. Therefore first I go to bring the exponential in front. At the time we can replace d in terms of d plus a. So this is the term. So now x square into cos x. So this is nothing but cos x I can write in the form of real part of e power ix. Again I bring this e power ix in front. Therefore this is nothing but d plus I. Wherever d in term we can replace d plus a. Here a is nothing but I. Therefore we can square it. We will get this. So therefore here I can replace this term. So therefore we can bring it into numerator. So we will get whole inverse. Next we have to replace 1 plus x square plus up to etc. So up to third term only we have non-zero value. After that it's a 0. So therefore replace it. We can solve it. We will get a solution. Therefore a real part. Finally we can split the real part. Only we have to take in the account of real part. Omit the imaginary part. Therefore particular integral is this. Therefore the general solution y is equal to complementary function plus particular integral y is equal to, which is the solution. So next, solve d square minus 2d plus 1 into y is equal to x into sin x. So the auxiliary equation replaces d in terms of m. So m minus 1 the whole square equal to 0. M's are 1 comma 1. Therefore the complementary function is this. Now we need to find the particular integral. So e power ix is cos x plus I sin x. So therefore imaginary part of e power ix. So bring this imaginary part. Again I go to bring this exponential in front. Now we can replace d in terms of d plus a. Here a is I. Therefore wherever d is there we can replace d plus I. Expand it. So and simplify this. So now we bring it to numerator. It will be inverse. So expand it. Only first derivative only exists. Remaining derivative tends to 0. So therefore we will, after simplifications, we will get this. Finally you go to split the imaginary part. So therefore once you splitted the imaginary part, we will get particular integral is equal to 1 by 2 into x cos x plus cos x minus sin x. So therefore replace your complementary function plus particular integral. We will get the solution. So these are the some problems for your practice. You can solve it. After solving, you will check your